Have you ever been puzzled by a compiler error that just doesn't seem to make sense? You're not alone. Today, we're diving into a common question. Why does the compiler not give an ambiguous reference error? I totally get it. Compiler errors can be frustrating, especially when you think you understand the code. Many developers have faced this exact issue, and it can leave you scratching your head. Let's set the stage. One user recently asked, "Why does the compiler not give an ambiguous reference error for my code?" They provided a snippet that includes a function called change, which seems to cause confusion. Sound familiar? Let's explore this together. So what's happening here? The user believes the reference to the change function is ambiguous, yet the compiler throws a different error. This can be confusing, but it often comes down to how templates and function overloads work in C++. Let's break it down. And stick around. By the end of this video, you'll not only understand this error, but also gain insights into how C++ handles templates and overloads. Trust me, you won't want to miss it. To understand why the compiler does not give an ambiguous reference error, we first need to look at how the function bar is defined. The user should note that bar is a variadic template function, which means it can accept any number of arguments. Next, the user should consider the types of the arguments being passed to bar. In this case, the user is passing an integer, a double, and a reference to the change function. The compiler needs to deduce the types of these arguments. Now let's focus on the change function. The user has two overloads of change, one that takes a constant reference to a string, and another that takes an integer. The ambiguity arises because the compiler cannot determine which overload to use when passing the function pointer. However, the error message indicates that there is no matching function for call to bar. This is because the compiler is unable to match the provided arguments to the expected template parameters, rather than directly indicating ambiguity. In summary, the user should understand that the compiler's error message reflects its inability to match the function call to the template rather than explicitly stating that the reference is ambiguous. This behavior is consistent across different compilers. Fun fact, did you know that C++ was originally designed to enhance the C programming language with object-oriented features? It's evolved a lot since then, but some quirks remain, like this one. Now, let's look at the answers provided by other users. In this alternative approach, the user explains that the compiler does not report an ambiguous reference error because it assumes the lookup will be unambiguous. They detail how the error occurs during overload resolution, specifically when the function call to bar is made with too many arguments. The compiler checks for viable candidates and emits a diagnostic based on the number of arguments provided, rather than the ambiguity of the function reference. Here's a pro tip. When working with templates and overloads, always ensure that your function signatures are distinct enough for the compiler to differentiate between them. This can save you a lot of headaches. And there you have it. Now you understand why the compiler didn't throw an ambiguous reference error. Remember, understanding how templates and overloads work can greatly improve your coding experience. If you found this helpful, hit that subscribe button for more insights.